All right, today we are going to look at lesson 13.3. If you have a book, it is on page 427. Once again, it is lesson 13.3. So if you follow along in Seesaw or into math, it is lesson 13.3. And it's on page 427. All right, so today we are going to compare means using mean absolute deviation and repeated sampling. So mean absolute deviation is something I believe that you were supposed to learn last year. But once again, because of COVID, we didn't learn a lot of things. All right, so we're going to use the means and the MADs to access the amount of visual overlap of two numerical data sets. All right, so you're going to need a sheet of paper. So if you are doing it in your book, you're going to need an additional sheet of paper because they don't give you enough room to do some of the things that we need to do today. Okay? All right, so it says, Eli collected data from 10 randomly selected 7th graders about the number of text messages they sent in one day. Results are shown in the table. Recall that the mean absolute deviation is the average distance from the data point to the mean. It is a measure of spread, so measure of spread of the data because it describes the variation of the data values from the mean. So what is the range of the data? What is the mean number of messages sent in this sample? So it's two questions here. So what is the range? Okay, so in order to do that, we need to know what the highest number is, and that looks like 119. And the lowest is 70. So the range would be 119 minus 70, which is 49. Okay? The mean, remember, is we're going to add all these up. So 104 plus 92 plus 107 plus 83 plus 96, 98, 70, 91, 119, and 90. All right, so 950. That's what all that adds up to be. And we know that we sampled 10 people. Okay, so then it's a power of 10, so all we need to do is move the decimal point. So I know the mean is 95. All right, so when we find the mean absolute deviation, and that's why it's called absolute, is we have to use the absolute value and we have to use the mean. So the first thing you have to do is find the mean, which is what we did. Okay? Then you subtract the mean from every data point. Okay? So for example, my first data point is 104. So we're going to do 104 minus 95. It is the absolute value, so my answer will always be positive. Okay? Then you go to the second point. 92 minus 95 we know is negative 3. But it's inside the absolute value, so it gives me positive 3. Okay? 107 minus 95 is 12. 83 minus 95 is negative 12, but it's in the absolute value, so it's positive 12. 96 minus 95 is 1. 98 minus 95 is 3. 70 minus 95 is negative 15. But once again, absolute value, so it is 15. (91) minus 95 is negative 4. But because it's absolute value, it's positive 4. 119 minus 95 is 24. And 90 minus 95 is negative 5. But because it's absolute value, it is 5. All right, so when we do mean absolute deviation, we have to add or take the sum of all the absolute deviations. Okay, so we're going to add 9 and 3 and 12 and 12, 1, 3, 15, 4, 24, and 5. You're going to add all of that together. And when we do that, we get 98. Okay, so then it says find the mean absolute deviation by finding the mean of the absolute deviation. So we're going to take the 98 and we're going to divide it by 10 because we still have 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know since it is a power of 10, we just move the decimal point. So it becomes 9 and 8 tenths. So the mean absolute deviation is 9 and 8 tenths. Okay, so that is the spread. So that is the average that the points are away from the mean. That's what that means. Means absolute deviation. All right, so it says which data point have an absolute deviation that is less than or equal to the MAD. Okay, so our MAD is 9 and 8 tenths. So we want numbers that are less than that. Okay, so 9 is less than 9.8. So my data point was 104. 3 is less, so my data point is 92. 12 is not less, so 107 does not work. 12 is not less, so 83 does not work. 1 is less, so that data point is 96. 3, so that's 98. 15 does not work. 91 does work. 24 does not. And then 5, which data point is 90. So those are the only data points that are below the MAD. Okay? So the turn and talk is what I just mentioned. How does the mean absolute deviation describe the data differently than the mean? So the MAD is the average distance from the mean. It describes variability in the data. Rather than the center of the data, like the mean. Okay, so the mean kind of tells me what's in the center. The MAD is what is the distance from that center of each point. So that's what that tells me. All right, can I move on? All right, I'm not hearing any no's. All right, so number 2 says, Quentin collected data from the numbers of minutes students spent completing a math puzzle at the beginning of the year and at the end of the year. So we're going to complete the table. So we're going to find the mean. And remember, we find the mean by adding all the data points. So we're going to add 12, 18, 20, 16, 11, 14, 16, 22, 17, and 14. So when I do that, I get 160. And we have 10 data points. So the beginning of the year, the mean is 16. All right, at the end of the year, when I add them all, it is 70 divided by 10. So at the end of the year, the mean is 7. Okay, so now we want to find the MAD. Okay? So this is where you're going to need your paper, because as you can see, they don't give you much room to do this. So my paper is here. All right, so I'm going to rewrite my points. So 12, 18, 20, 16, 11, 14, 16, 22, 17, and 14. All right, so there's my data point, so I don't have to keep kind of going back and forth. All right, so remember, it's the absolute value of the data point subtracted from the mean. And the mean of the first one is 16, and the mean of the second one is 7. All right, so absolute value, 12 minus 16. So that would be positive 4. Absolute value, 18 minus 16. So that would be 2. I'm just going to draw a line down for absolute value. So 20 minus 16 is 4. 16 minus 16 is 0. 11 minus 16 is 5. 14 minus 16 is 2. 16 minus 16 is 0. 22 minus 16 is 6. Oh, y'all can't even see that. Sorry. 17 minus 14 is 3. Oh, wait, that's not right. 17 minus 16 I don't even know where I got 14. That should be 1. And then 14 minus 16 would give me 2. Okay? So to find the mean absolute deviation, I'm going to have to add them. So 4 plus 2 plus 4, so that's 10, right? 15, 16, 17, 18, 19, 20, plus the 6 would be 26 divided by 10. All right. So the MAD of this one would be 2.6. Okay, then we do the next one. So I'm going to go ahead and just draw a line for my absolute value. Now my mean is 7. So 12 minus 7, 6 minus 7, 3 minus 7, 4 minus 7, 9 minus 7, 4 minus 7, 5 minus 7, 8 minus 7, 9 minus 7, and 10 minus 7. All right, so add all those up. So this would be 9, 10. This would be 6, 7, 8, 9, 10 again. So it looks like 25. Did I add it wrong? So 9, 10, 5, no, 6, 7, 8, 9, 10.
26.
Yeah, it should be 26. You're right. All right, so that gives me the same MAD. So they both have the same MAD. Okay, so I'm going to move that over. So this would be 2.6 and 2.6. So they have the same MAD. All right, so B says the MAD for these data sets happen to be the same. Compare the difference of the means to the MAD. Okay, so 16 minus 7. So that would give me what?
9.
Yep. And then my MAD is 2.6. So that one doesn't matter which one I take. Okay? So 9 divided by 2.6. So 9 divided by 2.6 gives me a very long decimal. It tells me to round to the nearest tenth. So the 4 is the tenth. So the 6 makes it go to 3.5. So the difference of the means is 3.5 times the MAD. So that means it's 3.5 greater than what the MAD is. Okay? So that's important to know this difference. Because when we graph the data, which is here, right, January and June, it tells me how much overlap we're going to have in the data set. So that's what it says. When two data sets are displayed in dot plots, the points might overlap a lot, a little, or not at all. The centers might appear to be close or far apart. The ratio of the difference of the means to the MADs can help you predict how much separation there will be between the two distributions. The greater the ratio, the greater the separation. When the MADs of the data sets are similar, these ratios will be similar. These plots show the puzzle solving data. Yellow shading shows the values with the mean absolute deviation. And so I know you can't see that. So let me show you what it kind of looks like. Okay, so it says the yellow shading shows the values within the mean absolute deviation. So remember, 2.6 is the MAD. So if I go back and look at those numbers, so 18 is in that deviation, right? Here's that one. Here's one that's less than. Here's another that's equal or less than. Okay, so all the ones I starred. So 18, 16, 14, 16, 17, and 14. All those numbers are in yellow. If I do the same here, right? Less than or equal to 2.6. Here's 1. There's 2. There's 3. There's 4. There's 5. So those numbers are between 8, 5, here's a 5. So between 5 and 9. So here's 5 and 9. So that is yellow. So those are all the data points that are within the MAD. Okay? And then here's the difference of the means. That from here to here. So 7 to 16. So then the question says, what does the ratio you calculated in part B tell you about the separation between the two distributions? So remember it said the larger the number, the larger the separation. So that's what we're going to write. There is a large separation between the centers of the data and not much overlap in the two distributions. Okay, so with that said, you can see there's only one number that actually overlaps. So that's how I know with the larger number we're not going to have much overlap. Okay, questions on that page? All right, so let's look at example 3. Okay, so before we even do the MAD, look at our data. Everything overlaps but these 2 points and these 2 points. So your ratio is probably going to be a lot smaller than what we just did. So we just had 3.5, right? So the ratio is going to be a lot smaller. All right, so let's look. So first thing we have to do is find the mean. So you're going to add 58, 60, 62, 62. And then 64, 64, 64, 64, 65, 65, 65, 66, 66, 66, and a 68. We're going to add all that together. And when we do, we get 764, and we have 12 data points. So 764 divided by 12. So my mean is 63.666, and we are going to round it to the nearest tenth. So 63 7/10. All right, then you're going to do the same thing here. So we're going to add 62, 64, 64, 64, 66, 66, 68, 68, 68, and 70. So you're going to add that. Oh, and I forgot 72. So we're going to add all that together. That gives me 800. So 800 divided by 12 is 66.7. 66 7/10. All right, so you're going to need another sheet of paper, or if you didn't take up the whole sheet from the last one, you can use the same. So I'm going to use another sheet. All right, so I'm going to rewrite my numbers. So 58, 60, 62, 62. 1, 2, 3, 4. 1, 2, 3, 4. Wait, something's not right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I don't have something right. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I don't have a 65. Where did I get 65? Yeah, this up here is not right. I don't even know where I got that. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. All right, and then the bottom should be 62, 64, 64, 64, 66, 66, 68, 68, 68. All right, so 1, 2, 3, 4, 5, 6. 1, 2, 3. Yep, okay. All right, so remember, we're going to do the absolute value. So the mean of this one is 63.7, and this one is 66.7. All right, so I'm going to go ahead and draw my line. All right, so 58 minus 63.7. So you're probably going to need a calculator, guys. So 63.7 minus 58. So it gives me 5.7. Okay. 60 minus 63.7. So 3.7, right? So 63.7 minus 60, 3.7. All right, so 62 minus 63.7 would be 1.7, right? So 63.7 minus 62 is 1.7. And we have that twice. All right, then we have 64 minus 63.7. So that is 3/10. and we have 4 of them. All right, then we have 3 66s. And I'm just going to draw an arrow on those so we know that those are the same. All right, so 66 minus 63.7 is 2.3. All right, and then the last one is 68 minus 63.7. So 4.3. All right, so we're going to add all of those up. So when I add all them up, what do I get? So 5.7 plus 1.7 plus 1.7 plus 0.3. And then 2.3, 2.3, 2.3, and then 4.3. So I get 25.2. Did anybody else add it?
Yes, ma'am.
What did you get? Same thing?
Yeah, I got same thing.
Okay. And then we had 12 data points, right? So 25.2 divided by 12 gives me 2.1 as the MAD. So go back up here and put 2.1. Alright, then we do the next one. So once again, I'm going to draw my line. Now we're going to use 66.7. So 62 minus 66.7. So what do we get? 4.7. All right, and then we're going to do 64 minus 66.7, which is 2.7. All right, and then we have 1, 2, 3 of those. So I'm just going to draw an arrow. And then we have 66 minus 66.7. And we have 2 of those. So that difference is 0.7. And then we have 68 minus 66.7. And we have 1, 2, 3, 4. And that gives me 1.3, is that right? So 68 minus 66.7. Yep, 1.3. So 1 and 3/10, 1 and 3/10, 1 and 3/10. And then I have 70, 3.3, and then 72 is 5.3. All right, so add them all together, and what do we get? I get 28 divided by 12. So I get 2.3 is the MAD. All right, so 2.3. Now, hopefully you notice the MADs are different. So my ratios are going to be different. Okay? We're still going to find the difference of the means. So we're still going to do 66.7 minus 63.7. Which is 3. So that would be the same, but the MADs are different. So the MAD for 6th grade is 2.1. The MAD for this one is 2.3. Okay? So if I divide 3 divided by 2.1, I get 1.428. So I'm going to round that to 1.4. Okay, same thing here. 3 divided by 2.3 gives me 1.3. Okay, so it says, what do the ratios you calculated in Part C tell you about the separation between the two distributions? So, the distance between the means is less than 1.5 times the MAD. So 1.4 is less than 1.5, 1.3 is less than 1.5. So the centers are fairly close, and because it's 1.4 and 1.3, it's not a complete overlap. So a complete overlap would be something like 0.5 or 1. That's pretty close, okay? So there will be some overlap in distribution. And that we noticed that right at the beginning. So if we went back and looked, we saw that there was some. So between that and that, there is some. So that's what that is mean. That's what that is telling us. All right, so we have about 6 minutes. I want you guys to work on the check understanding. Okay, see if you can do that one without assistance. We take the difference of the means and divide it by the MAD. So 0.5 divided by 1. So that gives me 0.5. So there is going to be a lot of overlap. A lot of overlap because it's 0.5. Okay? All right, so the MAD for the teens is more than 4 times the MAD of the adults, and the variation for the teens is much greater than the adults. Okay? So if you would have added these together, all right, well, we'll look at this one tomorrow, okay? All right, guys, see you tomorrow. Have a great day.